So mainly in these chapters, you should know certain things actually before getting to the chapter. First thing you should know what you mean by chemical formula. So you should know chemical formula, how to write chemical formula. So in ninth class, there is a method called crisscross method. Yes, so just a minute. Crisscross. So there is a crisscross method to write the formula. So there we need two things. One is called a symbol of specific element actually, and second thing you should know valency, or we can take charge also. Charge without a sign we are taking charge as. So let me write one example outright. So suppose in the last video we discussed about these things. Suppose we have I want to write formula for aluminium sulfate. Aluminium sulfate formula I want to write. Then I should use the symbol of aluminum is Al, and sulfate will be written as SO4 and charge will be -2. Then valency of aluminum, the table will be given as 3. This will be here we have 2. I will take 2 as a valence here. Then this valence should exchange each other. Then it means valence of sulfate should be given to the aluminum, and that of the aluminum valence should give to the sulfate. So I'll get here Al 3 times and SO4 we can write down. You should write bracket here because 4 and 3 different numbers are don't need to multiply here because this 3 belongs to both sulfur as well as oxygen. So I'll write this is Al2 Al2 SO3 SO4 taken thrice. This is an formula of aluminum Al2 SO4 taken bracket thrice. This is an formula of aluminum sulfate. This is the way what we discussed last video about chemical formula and all. So in this chapters, why you should know, because certain questions are there where they will give the chemical names they'll give, and in that we write the balanced equation. So if you don't know the formulas and all way of writing formula and all, it is very difficult for you people. So anyway, in this chapters, first main thing you should know what do you mean by chemical change actually. So already chemical change is nothing but, so in seventh class chemical change. Seventh class, we discussed that about chemical change and physical change. Physical change means we know very well. Then properties are the like shape, size, volume, color. These are physical properties. Change is going to occur with respect to these things we can call as physical change. And whereas in chemical change, there must be an formation of new substance. Okay, and it should be an irreversible in nature, and it should be an permanent change. It should be an permanent change. These two things are important here. So let me discuss an example. So if I have a pepper powder, we take pepper powder. Okay, pepper powder. I'm adding salt for this one. After mixing these two, we'll get a mixture. Get a mixture. Just think like this is case one. Similarly, I will take example of hydrogen gas. I'll take hydrogen gas, and I will take I'm going to burn this hydrogen gas. So after burning, we'll get substance called water. Okay, just remember here. So two things we are discussing. Try to understand here. One is we are taking pepper powder. This is pepper powder and salt. See, you know very well pepper will be spicy in nature and salt will be salt in nature. So when we are going to taste this mixture, so you'll get both spicy taste also as well as salty also. Because that I understand here, in this mixture, whatever things we are mixed here means pepper powder as well as salt we mixed here. No? They will not lose their original properties. Okay, so just they are together but they doesn't did not lose their properties. That's why we can call it will be a mixture, we can say. So we can say even the mixture. These kind of things we are calling as just two substances are together each other without losing their original characters and all. That kind of things is called as mixture we are calling. But you see here, hydrogen will be having a fuel character. It have a fuel character. It have a fuel character, and this oxygen have a properties of supporting fire. So it will supports fire, very well. Supports fire. So when it is, but if you take an water here, these two will, we are saying these two will react each other. These two are undergoing a reaction of chemical change, and they are forming a new substance called here water. This water have a property of, very well, for what purpose we are using water to put off the fire. Put off the fire. Let's remember, put off the fire. So these things, when they are in the individual form, they have a certain properties, and when they undergone the chemical change, they lost their original properties and they form the new substance. Why it is called new substance? Just remember here. So what do you mean by new substance? Why we need to call this water as a new substance? Okay, water is called as a new substance. Why? Okay, so this second case we are calling, second case we can call it as a what we can say, second case, second example we can give for the chemical change. Okay, this we can call as, this is we can call as some chemical change. Okay, chemical change. This will be taken as what? So this is nothing but physical change. So why? Because the physical properties are changed here, not the chemical properties. Okay, physical change, because physical properties are changed. You can say okay, physical change it is. Okay, so in chemistry, so let me discuss about first para in this chapters what they given actually. As you can see here, they given certain examples they given. So these examples, milk is left at room temperature during summers, and iron tawa fan oil exposed to the humid atmosphere. Grapes are fermented. Food is cooked and food get digested in our body. And these are certain examples which will describes about which are the chemical change. So along with that, they given here, the given certain things here. Just to remember here, in this all, in all the above situations, the nature and identity of metal, identity of initial substance have somewhat changed. So we have already learned about physical and chemical change in the chemical change of matter in our previous classes, that is class 7. Whenever chemical change occurs, we can say that chemical reaction has taken place. So here they given certain examples also. So what do you mean by chemical change actually? Just we discuss certain example they given here. So let me write here. So they given examples. They given here. This one they given about. I think this milk is left in summer for certain time in atmosphere. Then it will turns into curd. So you know very well properties of curd is different and those of the milk is different. That's why it is also comes under the chemical change. And after they give an example of iron tawa. So this iron will react with atmospheric oxygen, and there is an humid day they given water will be there. It forms some things, iron oxide. Iron oxide will form. So this iron oxide we know very well, it will be an reddish brown color. So which is different compared to the pure iron. Okay, this is also example for chemical change. Certain then after they given cooking also is a chemical change. We can say why, because food will be food after cooking is different, and before cooking is different. So we can't reverse it. You can say irreversible nature. Similarly, digestion they given. So we know very well digestion, carbohydrate will be there in food, C6H12 O6, and plus we are going to respirations. We are taking oxygen. So after this one, we are getting carbon dioxide and S2O. Along with that, we are getting the energy. That is the purpose why we are taking the food. Okay, so this is also example for chemical change. Along with this, they given uh, an examples they given. Just we can say You can see in the diagram they given about magnesium ribbon. So you can see here this activity they given they given activity you can see here. So there is an clean the magnesium ribbon about 3 to 4 centimeters long by rubbing with an sandpaper. Hold it on paper, pair of tongues and burns it using spirit lamps and burners and collect the ash soda. So formed in the watch glass as shown in the figure 1.1. Burn the magnesium ribbon, keeping it away as far as possible from your eyes. What do you observe? So they given here. Again, one more example for chemical change. Just describe the activity, what they given actually here. So in this activity, try to understand. First point, we should understand that the first point they given there is a magnesium ribbon. Okay, so magnesium ribbon. Remember, magnesium have a symbol of Mg, capital M, small g. Magnesium ribbon need to rub with an sandpaper. Why rubbing with a sandpaper? Rubbing with sandpaper. Why you should rub with the sandpaper, sir? Reason is before burning, after, above the this suppose this is an magnesium ribbon you think, and above this there is an oxide layer will be there. Okay, oxide layer. This oxide layer can be removed with what, sir? Sandpaper. Otherwise, it will not burns in the flame. It will not burn in the flame. Okay, that is first thing. Second thing you try to understand. So what we are doing here, we are taking magnesium. We are taking magnesium. Okay, we take here magnesium. Remember, magnesium. What we are doing, sir? We are magnesium is burning. Magnesium is burning. Remember, burning means what we get, sir? After burning, we get magnesium. Magnesium oxide, the form of what's in the form of ash. Remember, this is a new substance here. So this is a new substance. Along with when this magnesium is burning, try to understand it will produce a dazzling white color. Remember, it is producing dazzling white color. Okay, it will produce dazzling white flame, dazzling white flame. Yes, this is one example, remember. Then after one more example we'll discuss that about one more example taken in the activity. Yes, you can see they are taken. Let me see here what they given second example. So after this one they given about 1.1.1. So 1.2 will say that so we should take solution, different solution they given here. Yes, just a minute. So in second activity they given here, they are taking the solutions of two solutions they are taking. One is lead, lead, lead nitrate they are taking, lead nitrate. Okay, and they are adding lead nitrate solution. Remember, solution means what's a lead nitrate solutions? It is an, you can say it will be an colorless actually, colorless. And second thing we are taking potassium iodide. This potassium iodide solution. This is also we can say colorless. So both are colorless solutions. So when they are mixing each other, when they are mixing, what happens? They'll get a new substance. They'll get one is lead, lead iodide, lead iodide. Okay, which is yellow color, yellow color, and this will be, and remember, solid means insoluble. And one more substance will get lead completed, you get the potassium nitrate. This is another activity 1.2. Okay, one more activity is there, one more activity they given to understand this chemical change. So we can say a third activity. So I can say third activity will be there. So they given here third activity. What is third activity, sir? Actually, third activity they given about. Sorry, I given I told. So in third activity they given here, they are taking zinc metals. Okay, zinc metal they are taking zinc metal, zinc granules, zinc metal. They are adding for the added to added to dilute sulfuric acid. So right formula, sulfuric acid will be H2SO4. What happens there, sir? So we'll see that around zinc, around zinc, bubbles will form. There will be formation of bubbling will be there. Bubbling will take place. Slowly, bubbles will start to produce at the. Suppose you think like this is an conical flask. Okay, conical flask will be like this only. Just remember. Okay, so here they are taking things like this will be the dilute sulfuric acid. Okay, so here we are taking small piece of zinc, and here from here bubbles will start. Bubbles will start to form upon the surface of the zinc. So this gas will be there. This gas is nothing but hydrogen gas will be produced. Hydrogen gas will produce, and these are the examples they given, activities they given. So why they given this activity actually to understand the chemical chain. So you can see here, these are the activities they given here, three activity. So few things, just I said that lead nitrate solution is test tube added to potassium iodide solution to this, and what you observe. So here observe that there is a change in the color, which is both are colorless solutions. After additions, then we will get a new substance called lead iodide, which is yellow in color, and that too insoluble substance. Okay, when you see this activity, take the zinc in a conical star test tube, add dilute hydrochloric acid, and do you observe thing happening zinc granules? So zinc granules means small piece of the zinc. So we thought we discussed that. So when we are adding zinc and see around the zinc there is an formation of hydrogen gas in terms of bubbles. Okay, that we observed here. So these are by understanding all things we say, things are there. So in which we can thing is nothing but chemical change. So this above three. So from you can see the certain reactions are, we can see that following following observations to determine whether chemical changes are taking place. First one, see in a state or change in the color, evolution of gas, and change in the temperature. So as we observe the things around us, we can see that there is an large variety of chemical reactions taken place around, as we will study about various types of chemical reactions, a symbolic representation in the chapter. So here, these are the observations. So these are the observations where we can find out whether the chemical change taken place or not. Okay, so there may be changes. See, in this case, what we observe that we can say, so there is an evolution of gases. So I can say this will be the example for chemical change. Here also you can say there is a change in the color, right? Both are lead nitrate solution is colorless and potassium iodide solution also colorless. Where after reaction, both are reacting each other and they forming the new substance called lead iodide, which is yellow in color, and that will be solid, insoluble in nature. And along with one more solution was there, which is also colorless, potassium nitrate. And here you can see there is change in the color also. So when we are burning magnesium, magnesium oxide is going to form in terms of ash white color powder will get. Along with that, when magnesium is burning, undergoing combustion. In that time, remember, it produced what's a dazzling white flame. Not only dazzling white, what we can say, it will produce even other color also, dazzling white also. One more name they will, one more name is there, this called what we can say, brilliant white also. This also called a brilliant white, so we can say brilliant, brilliant white color flame is produced. This, remember that the chance of asking these names in the board examination, brilliant white, or we can say dazzling white flame is produced. And here in this case, remember, yellow color insoluble substance is produced. And one more thing, remember, so when come to this activity, so we saw that there is a production of hydrogen gas. So you can say in this cases, evolution of evolution of gas taken place. Okay, so this, understand these all things. By understand these all things, we can say the given change is chemical change. And in these chapters, we can say here certain things you need to remember here. What is that, sir, actually? So in the, see, in this, these things are there, this chemical, so chemical change is also called chemical reactions. Chemical change also called chemical reaction. And this explaining about chemical reaction somewhat long process, or that's writing in the form of sentences will take much more time. So we can make it in a I mean short form, that is we are calling as a, suppose we are talking about burning of magnesium ribbon. So burning of, what's a magnesium ribbon. So to explain about these all things, I want to make it in a short form. So what I will do actually? So what I will do is, instead of explain these all things, burning of magnesium ribbon, we took magnesium ribbon and rub with the sandpaper to clean the magnesium oxide layer upon magnesium. Then we kept in flame with the help of pair of tongues and all. So I want to make in a short form. That's why I'm writing this process in terms of words. In terms of words, okay. This is called word equation. So what, how I'll write actually here. Okay. So what I'm doing here, chemical change is taken place, and that I want to write in the form, in the short form. So I'm writing in terms of words. Okay. So what I'm doing, sir. So what are the substance are taken place here? We are involved in the chemical chain. One is first magnesium. So magnesium, I'm writing here magnesium. So magnesium is taken part in the chemical chain. That's why magnesium is called. Just let me write complete equation. This is we burn. That's why we require what, oxygen. So I'm writing here oxygen. Okay. So after burning, what we got, sir? We got a new substance called magnesium. Okay, magnesium oxide. So this is word equation. Remember, I'm using words here. That's why it is called word equation. That's why it is called a word equation. Remember, okay. So now, what I'm doing, magnesium oxide here. These two things are there. No? One is magnesium, one is oxygen. These are taken part in the chemical reaction. That's why these two things are called reactants. So what do you mean by reactants? Are reactants are the substances which are take part in the chemical reaction, or which are involved in the chemical reaction, which are participated in the chemical change, or called words are reactant. How we should write a word equation actually? See this word equation, we are taking reactant in the left side. Between them, I'm writing a plus symbol here. If more than one reactants are there, then we're writing arrow mark here. And after the arrow mark, I'm writing the new substance. So you got, what is mean by new substance actually? New substance means made up of same thing only, but they have a certain set of new set of properties. So new set of properties, new set of properties means the properties of the this magnesium oxide is entirely different from those of oxygen and magnesium. That's why it is called new substance. New substance is called what's a product. Another name for a new substance is product. But you should write after the arrow mark, right side of the arrow mark. This is called right hand side of the arrow mark, and this is called left hand side of the arrow mark. Where when you write reactants are left side, more than one reactants are there. That's why we're writing the positive sign between the reactant, and right side you can see right hand side there is only one product, which is magnesium oxide. That's why we're not writing any plus. If it is more than one products are there, again in between them also we need to write the positive sign. Okay, so this is called word equation. So now again there is a problem that this is also somewhat quite large. So now what I will do, so I want to write other again in a short form. Again, I want to make this equation again further short form. That's why I'm writing in terms of in terms of symbols, and formula, some numbers also, formulas. Okay, and some numbers also you can use. Okay, so this is called chemical equation. This is called what's a chemical equation. So if we are representing chemical reaction in terms of word means what's it is called a word equation. It's called word equation. In terms of symbols, shorthand representation of chemical reaction in terms of words, in terms of symbols and formula, is called what's a chemical equation. Example, we written upside what's a magnesium. Now what I'm doing, I'm writing only symbol of magnesium is Mg plus what is the formula of oxygen, sir? We are writing as O2. So it forms what, sir? It forms MgO. Again you see here magnesium is reactant written left side, oxygen is reactant left side. Again magnesium oxide is a new substance means product writing on the right side of the arrow mark. In this process, this arrow, head of the arrow represent direction of the reaction. So what it represents are direction. Which direction? Reaction. Direction of reaction. So it represent what's that? It represent which direction reaction is taken place. This arrow should be towards what's that? Products that indicate direction of the reaction. Okay, so this is how we are writing chemical equation. Again, this chemical equation are the two types are there. Again, this chemical equation two types are there. Let me write. Okay, so one is first one is we are calling as a first one we are writing as unbalanced chemical equation. Unbalanced, unbalanced chemical equation. So what do you mean by unbalanced chemical equations, sir? Unbalanced chemical equation, remember here. So before this one, you try to understand here. Just rewrite the equation. One magnesium we written, and there is an two oxygen we written, and we got the magnesium oxide, right? So just to find out mass of the magnesium atomic number is 12, and mass number will be 24 AME or 24 unified mass. If I taken the mass of one oxygen mass number is 16, two are there. That's why we are taking as 32 unified mass. So in magnesium, how many magnesiums are there? One magnesium, 24 unified mass, and there is an one oxygen. That's why I'm adding a 16 unified mass. So here you can see here total mass will be 24 to 56 unified mass, which is not equal to 24 plus 16. I think it will be an 40 or 40. Okay, which is not equal. So mass of the reactants is not equal to the mass of the products. That's ninth class we study something called LCM. Do you know about this LCM? LCM means not mass LCM. It is a chemistry LCM also. Okay, so we can say it is called as a law law of law of conservation of conservation of what's a mass. So what it state that? So it state that mass of element in chemical reaction is neither be created nor be destroyed. It remains the same. This is given by law of conservation of mass. Okay, law of conservation of mass. Okay, and which law, which chemical equations obey the law of conservation of mass? This is called balanced chemical equation. Now see, as we discussed here in terms of magnesium, oxygen, we got magnesium oxide, and here we got 24 plus 32, plus here we got 24 plus 16, you got here total it will be an 40, it will be an around 56, which is not equal. You can see here it's mass of the react, these are called reactant, right? These are called product. Mass of the reactants is 56 unified mass, and mass of the products are 40 unified mass, where both are not same. That's why what we can say, it is not obeying the, it is not obeying the, what's that? This one is not obeying the LCM. LCM means what's that? Law of conservation of mass. That's why we can say this kind of equation is called what's that? Unbalanced. Unbalanced chemical equation. There is another one more name is that is called skeletal. Skeletal chemical equation, remember. Okay, this kind of equation where it is not obeying the law of conservation of mass. Okay, so now how we should make this equation to obey the law of conservation of mass? So just there is some simple modifications are there. It is called a balancing also, it is called balancing equation also. So just remember here, just I'm taking here same equations. Then take magnesium plus oxygen gives rise to magnesium oxide. Okay, now see these are reactant. How many magnesiums are there? One magnesium, one magnesium. How many oxygens are two are there? So I'll write here two here. So just remember, just a few seconds. Okay. Yes, what I will do, I write here two here. So two magnesiums are two, oxygens are two. I will write here. So now how many magnesiums are there? Two magnesiums are there. How many oxygen? Two oxygens are there. So now again what I will do, I will write here two. Now see here. Now calculate mass here. Two into, what is the mass of magnesium? 24 plus what is the mass of oxygen? Two into mass number is 16 is equal to gives us to two into magnesium, two into 24 again plus two into 16 is there. Okay, so 2 into oxygen, 2 oxygens are there. So 248 plus 32. So here also what will get, sir, here? 48 plus 32. So approximately what will get, sir? 48 plus 32. So we get here what's, sir? 80 unified mass. Here also we get what's, sir? 80 unified mass. We can say both are equal. So now this equation, which equations are? This equation, this equation is obeying what, sir? This equation is obeying the law of conservation of mass. So this kind of equations, which kind of equations are the kind of equation which is going to obey the, which is obeying the what's, sir? Law of conservation of mass are called balanced equation. Balanced, balanced chemical equation. So now there is a need how to balance chemical equation. This is quite normal equation, so we'll balance certain equations are there, somewhat quite larger. How we can balance them? That we are going to learn now. Now next one is there is an yes, we can go through this. So you can see that they given here. One more example they given here, writing chemical equations, and okay, so two types are there. One is called balanced, another is called unbalanced. So let we discuss about one more example. Okay, now see, now we discuss some other equation, right? Some other equations we discussed. Okay, now we discussed about some examples, right? So what we did, sir, we added zinc in the sulfuric acid. Okay, so what will get, sir, here? We get a ZnSO4. plus. So we'll get Zn is support plus we'll get a hydrogen gas. Now see here. Now how many zincs are there here? How many zincs? There is an let we write there is an zinc in this equation. Then we have hydrogen. Then we have sulfur. Then we have a oxygen. Let me write this is on left hand side. This will be the right hand side. So zinc, how many are there? One zinc here also one zinc. Two hydrogens are there, two hydrogens are there, one sulfur and four oxygens are there, four others. So only to balance already everything are same on the both side. I mean number of kind of elements on the both the reactant side and product side both are same. No need to worry about this kind of equations. Why? Because it's already balanced equation. So why we need to balance equations, sir? Again, as we discussed already, to obey the law of conservation of mass. Law of conservation. To obey the law of conservation of mass, we need to balance equations. Or else simply we can say which equation is called balanced means we can say the chemical equation which is going to obey the law of conservation of mass is also called balanced chemical equation. Let me balance one more equation which is given in textbook. There is given Fe plus H2O. Fe plus H2O gives rise to Fe3O4. Fe3 they given Fe3O4 plus they given hydrogen. Okay, so what is the first step, sir? First step is step one should write boxes. Where should write boxes, sir? Should write the boxes around all the what called reactant and products around the this is iron. I'm writing box here. Again I'm taking boxes around water and I'm writing boxes around okay, writing box around this hydrogen. So why we need write boxes, sir? Because the certain things are there whatever inside the boxes they are specific formula of particular compound. You should not change the number which is present inside the box. That is the purpose why we need to write boxes around the reactant and product. Then where you should change the number. This place is these places are called before the formula. This places is called coefficient place. Here we need to write the whatever number we need to write during the changing the this numbers and all. Okay, now see I want to balance here. So this is the first step. Second step what, sir? Second step is list all the all elements. So we'll come to know how many elements are there on both side. Okay, on both side different kind of elements. And then suppose we have in this equation we have iron, we have hydrogen, we have oxygen. So let me write this is left hand side, reactant side. Left hand side is also called reactant side. Okay, and right hand side which is also called product side. Okay, so product means remember new substance formed in the chemical equation. Okay, chemical reaction of equation. Okay, now see how many irons are left side. One iron is there. Right side how many are there? Three are there. How many hydrogens are there? Left hand side two are there, sir. How many hydrogens are right hand side? There also two are there. How many oxygens are there? One oxygen. Right hand side how many are there? Four are there. So we made a list now. No, we made a list. Okay, there are a number of. So we listed right. Okay, now after list you will come to know which reactant or which reactant or which product contain more number of elements. More number of elements. Why you should count this? Why you should know these all things? Because so which you should choose. This method is called actually this kind of method is called this kind of balancing method is called hit and trial method. Hit and trial. Hit and trial method. Okay, then trial method they will call as 10th class is concerned. This method is generally used. There are certain methods are there, like the frequency number method, redox, oxidation reduction number methods, and all. Okay, those are not necessary as this is more enough. I think so. Just what we did here, first step, what we did, we draw the boxes, we draw the box around the reactants as well as the products, so that whatever things are there inside the boxes, we should not change, we should not alter those numbers which are present inside the boxes. Okay, that please remember. Okay, second step what we did, sir, we did a list of the all the kind of elements and number of elements on the reactant side, how many are there, and right side how many are there. And after you should choose the biggest formula, which is the biggest formula in the equation you should choose. Okay, so now I'm writing here. So again I'm writing here equation Fe plus H2O gives rise to what's that? Fe3O4 plus H2. Okay, plus H2. This is equation we written here. We written box around Fe. Then we written here also Fe. Okay, now see here how many irons are there. Which is the biggest formula, sir. So after listing the all the listed out all the reactant and product, we should find out which is the biggest formula. You see here in this Fe only one atom is there, and here there are two hydrogens are there, one oxygen, total three are there. Here three plus four, seven are there. Here two are there. So I'm choosing this is the biggest formula. Correct? Huh? This is the biggest one. Which is the biggest formula, sir? Fe3O4 is the biggest formula. So I'm choosing this one is as the biggest formula. I'll start balancing from here. Now again in that also, which one is having, which one have a more number of atoms here? Oxygen have a more number. That's why I'll start to balance from oxygen onwards. How many oxygens are there here? Four are there. Left hand side you should see where is oxygen. So there is an in the H2 there is an oxygen. How many oxygens are there here? The single oxygen, sir. That's why I'll multiply this water with the 4. Right? Understand? I am multiplying total water with 4 times. What I'm doing, I am multiplying H2O with 4 times, not only oxygen. I'm not writing 4 is here. Okay, this is wrong. That's why that specifically they mentioned that we should draw the box around the reactants as well as products, so that whatever numbers are there inside the boxes, we should not alter. Okay, so just so now what I will do, I write direct the equation. So Fe plus, so 4 is there, no? Fe plus H2O. So I'll write as 4H2O. 4H2O gives rise to Fe3O4 plus H2. So I'll written equation here. Now see again next is what, sir? We balance the oxygen. We should balance iron. How many irons are there? Right hand side. How many are there here? Three irons are there. How many irons are the right hand side, sir? There are three irons are there. So here is three irons are there. Here how many are there here? I'll multiply this one with the 3. So I'll write equation. This one I'm going to multiply with the what's that? 3. So I'll get equation as 3Fe plus 4H2O gives rise to Fe3O4 plus H2. Now we balance the iron as well as oxygen. Now we need to balance what's the last element, which is the hydrogen. Which is which ones are hydrogen we need to balance. So now I'll write equation. I'll write equation. Now how I'll balance hydrogens are, you can see here right hand side there are two hydrogens are there, and left hand side how many hydrogens are there? There are two hydrogens here. Two into 4 into 2, 8 are there. So I will multiply this with 4 into 4, so that both will be balanced. Now write equation here. I'll write 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2. Now see how many irons are there? Three irons are there. Fe3, three irons are there. 4 into 2, 8 hydrogens are there. 4 into 8 hydrogens are there. 4 into 1, 4 oxygens are there. 4 oxygens. Now it is called balanced chemical equation. Let me take some more examples so that you can easily understand the concept. So one more equation. So we can take C3H4. It is called generally. It is called, sorry, not C3H4. Just small change here. C3H8. It is called propane. Plus we are adding what's that? Oxygen gives rise to carbon dioxide and H2O. Okay, so it should balance now. Now we can balance just so we'll take C3, three carbons are there. I'm writing here three carbons. So carbon is balanced. How many hydrogens are there? Eight are there. Here four are there. Two are there. Two into four I will write here. Two into four. Again, so we stepwise better. You can balance stepwise here. Okay. Now we can take here this equation. Okay. So first one you should draw the box here. So this is the biggest formula C3H8 iron. So I'll start balancing here. Three carbons are there. I'm multiplying this carbon dioxide with three. So I'll get here C3H8 plus O2 gives rise to 3CO2 plus H2O. So we balance the carbonite. Right now we need to balance one more. So we balance the carbon now. There is an eight hydrogens are there. You can see right hand side there is on two hydrogens are there. So I'll multiply this water with the eight we require. Two into four is equal to eight. I'm multiplying with the four. So I'll get the C3H8 plus O2 gives rise to C3CO2 plus 4H2O. 4H2. It is balanced. Which one is balanced? Hydrogen. Now come to the oxygen. So we need to balance oxygen now. So we'll take here uh, oxygen. Here you can see there is a two oxygens are there. Here, three into two, how many are there? Six are there. Plus here four are there. Total 10 are there. So I will multiply 2 into 5 is equal to 10. So I'll get here C3H8 plus 5O2 gives rise to 3CO2 plus I'll get 4H2. This is where how we need to balance the equation. So you can see three carbons, eight oxygens are three hydrogens are there, four to the eight hydrogens are there, five to the 10 oxygens are there, three to the six are there, four and the four. Total 10 are there. Now it is balanced. So we'll take one more example. One more example we can take last example, so we can wind up the class better for today. This is more enough, I think so. So now one more example we'll discuss. Okay. Now we'll take example of C4 C4H10 plus O2 gives rise to CO2 plus H2O. So you can balance here. Four are there. C4. We'll multiply this thing with 4 because four carbons are there. C4H10 plus O2 gives rise to 4CO2 plus H2O. We balance the carbon here. So there are 10 hydrogens are there, here 2 are there. So I'll multiply with the 5 here. So I'll get here C4H10 plus O2 gives rise to 4CO2 plus 5H2O. Now we balanced four carbons, a carbon we balance, hydrogen we balance. So how many oxygens are there? We can see here. Here you can see there are 4 to the 8 options are there. Here 5 are 8 plus 5. We get 13 are there. Okay. 13 are there, but here 2 are there. So this is an even number. So here 2 is an even number. This is an you can say odd number. So in that cases, so what we should do? We should multiply whole equation with the 2. Then both sides will get a even number. So what I will do here? Now I will multiply with this equation with the 2 here. So we get 2C4H10 plus O2 gives O2 O2 no 2 O2 plus 4 to the 8 CO2 plus so 2 is there 2 into 5 10 H2O. Okay, now you got this one. So now you can see here again no need to balance all the things again one more time. So just whatever the leftover thing oxygen we need to balance, right? That's why we are going to balance only oxygen because same number only will get as we multiplied all the reactant and product same number. So 8 into 2, how many oxygens are there? 16 are there. Plus 10 into 1 oxygen, 10 oxygens are there. Total how many are there? 26 are there. Here 2 2s are 4 are there, so I'll remove this number. So I'll write change this number. So 2 into 13. So I'll get 26 here. Okay. Now what I'll rewrite this equation. Yes, remember here. So now we'll get what I'm doing and multiplying this one with the 13. Okay. So 2 into 13, 26. So we'll get 2C4H10 plus 13O2 gives rise to, so 8CO2 plus 10H2. Now this is balanced one. You can see here as to calculate. So how many carbons are there? So you can say carbon, hydrogen, and oxygen. So left hand side, LSS side, how many are there, and right hand side you see. So left hand side, how many carbon? 2 4 8 carbons are there. So 2 into 10, how many are 20 hydrogens are there? 13 into how many 26 oxygens are there. Right hand side you see 8 into carbon, 8 carbons are there. So next we have hydrogens. Where is that? 2 10 into 2, how many hydrogens? 20 hydrogens are there. 8 to the 16 oxygen plus 10 oxygen, 26. So all are balanced. So we can say this kind of equation is called what's that? Balanced chemical equation, or it is also called, one more name is that, this called stoichiometric stoichiometric chemical equation. Okay, so you'll find, just remember here today what we discussed here, once you can glance. Okay. So these are chemical change. What do you mean by chemical change and permanent change? New substance should be formed. And example, we taken pepper powder and salt powder. It is a mixture. This formation of physical change. This case, you see properties of hydrogens and oxygen completely vanished out, and water is formed, and which is new substance, because water have entirely different property compared to the hydrogen and oxygen. Such kind of change is called what's a chemical change. Again, they given certain examples at the beginning of the chapters, like milk converting into curd, and cooking is a chemical change. After the given iron fan tawa exposed to the humid atmosphere, which contain what we can say oxygen moisture, it forms iron oxide. This is called reddish brown, which is reddish brown in color. Cooking is also example for chemical change. Then after the given activities here, burning of magnesium ribbon, the given addition of lead nitrate solutions into the potassium iodide solutions, which gives the yellow color lead iodide solution. Lead iodide is insoluble substance. Then after the given addition of zinc into the acid, like dilute estrus of sulfuric acid, which gives the hydrogen gas, which is nothing but explains about evolution of gas. And this will be gives a dazzling white color, burning of magnesium ribbon. There is a change in the color, we can say change in physical properties. Oxygen is in the form of gas, but when it is in the form of magnesium oxide, it will become a solid state, we can say. Whereas yellow color precipitation is color change is going to take place, and after the given this chemical change also called chemical reaction. Chemical reaction we are writing in terms of what it is called word equation. Why you should write word equation? Because we want to make a short form. Okay, we want to make a short form. So how we written? We written magnesium plus oxygen gives us to magnesium oxide. The reactant need to write left side of the arrow mark, and between more than one reactants are there, between them you should write the plus mark. And if similarly more than one products are there, product need to write after the arrow mark. Okay, if more than one products are there, between them again, as we mentioned, positive sign between the reactant. Similarly, in the case of products also should write a positive sign between them if more than one products are formed. Okay, after you should write this word equation. Again we are writing in terms of symbols and formula, some numbers also. And in the place of subscript place, that is called chemical equation. Chemical equations are nothing but what's are shorthand representation of chemical reaction in terms of symbols and formula. And after again, chemical equations are two types are there. One is called unbalanced chemical equation, which is not obeying the law of conservation of mass. LCM, law of conservation of mass. So mass of the reactant is not equal to mass of the product, or number of atoms on the reactant side is not same as number of atoms on the product side, which is simply we can say which is not obeying the law of conservation of mass. And after we, there is an one more kind of equations which we are calling as balanced chemical equation, in which chemical equation is going to obey the law of conservation